Hi everybody, welcome back to this course on Internet Technologies. I'm Vardan and this video is all about Hypertext Transfer Protocol and its request methods. But before that, we need to know about the World Wide Web. So when we talk about the World Wide Web or the web in everyday language, we often confuse it with the internet itself, but they're not the same thing. The internet is the infrastructure, the global network of interconnected computers and routers. The web is a service that runs on the top of the internet. So the World Wide Web is a system that lets users access and share documents that can include text, images, audio, video, basically any kind of media. These documents are usually interlinked using hyperlinks, forming a web of connected content. These files or documents reside on web servers, also known as HTTP servers, and they're written in a special markup language called HTML, that is Hypertext Markup Language. When you open a web page, your browser fetches this HTML document from a web server and then takes care of how it looks. The browser formats, styles, and displays the document so it's readable and interactive for you as a user. Now, the core protocol behind the web is HTTP, which stands for Hypertext Transfer Protocol. This is the protocol that allows your browser, the client, to talk to the web server. Now, here's key detail. HTTP is stateless. That means the server doesn't keep any memory of your previous request. Each time your browser asks for a web page, the server treats it like it's meeting you for the first time again. So, if you request three different pages, your browser will make three separate connections to the server. Now, what do we mean by hypertext? Hypertext is simply text that contains links to other text. It's what allows the web to be this rich interconnected system. And HTTP is the protocol that transfers this hypertext between the client and the server across the internet. So the process of using HTTP is fairly straightforward. Here's what happens. First, your web browser, acting as the client, opens a socket connection to a web server. This connection is usually made on port 80, which is the standard port for HTTP. Once connected, the client sends an HTTP request asking for a specific document or resource like an image, a web page, or even a video. The server then processes the request and replies with an HTTP response which contains the document or resource the client asked for. As soon as that response is sent, the server closes down the connection. Remember, HTTP is stateless, so there's no need to keep the connection alive unless something like HTTP keep alive is used explicitly. When your browser sends a request to a web server, it follows a specific format called an HTTP request. The first line is the request line. It includes the request methods like get, post, or head. The path, which is the part of the URL that comes after the domain name, and the HTTP version, such as HTTP 1.1 or HTTP 2. Then come the headers. These are optional pieces of information that provide more context about the request, such as the type of browser you're using or whether you're accepting cookies or not. If the request includes a body, like in the case of a post request, there's a blank line separating the headers from the body content. This whole structure makes sure that the server understands exactly what you want and how you want it. So let's start with the most common HTTP method, get. When your browser wants to fetch a web page or a file, it sends a get request. You can also add parameters to this request, typically when submitting an HTML form. These parameters are included in the URL itself, like this: get slash search question mark q equal apple http slash 1.1. These extra bits of information like q equal apple are part of what we call URL encoded format. Spaces are replaced with plus signs or percentage 20. Special characters are encoded and everything gets squeezed into the URL. A quick example, if you're opening a telnet session and connecting to a web server, you might type something like get/test.html http 1.0 and the server will return the HTML file in the response. And the head method is very similar to get. It requests a resource from the server, but it only asks for the header, not the actual content. So why is this useful? Let's say your program wants to check if a file exists or what its last modified date was. You don't need to download the entire file, you just need the metadata. That's where the head method comes in. It's a way of saying, hey server, just tell me about the file, don't send the whole damn thing. This is also commonly used by crawlers and link checkers to validate whether links are still active without consuming too much bandwidth. While get puts data in the URL, the post method sends the data in the message body, which is why it's often used for things like form submissions, login details, or file uploads. This makes post more secure and flexible since sensitive information like passwords isn't exposed in the URL. It also allows for sending large chunks of data which get isn't really designed for. For example, if you're filling out a form to create an account, once you hit submit, the data, that is the name, email, password, is wrapped in the body of a post request and sent to the server for processing. And finally, we have the put and delete methods. Put is used when you want to upload a file or replace an existing one on the server. It's like saying, here's the updated version of this document, replace whatever's already there. Delete, on the other hand, does exactly what it sounds like. It tells the server to remove a resource. These methods aren't typically used when browsing websites, but they're very important when building REST APIs, like for web apps or mobile apps that manage data dynamically. Imagine an app where users can upload profile pictures with put or delete their old ones with delete. That's how these methods become useful in modern web development. And with that, we've come to the end of this video. And in the next lesson, we'll learn about HTTP response, proxy servers, and uniform resource locator. So thank you for joining in, and I'll see you next time.